Welcome to help video number 146 over Unit 1 test 1-13. This video will pick up with question number 47. 47 begins a section of multiple choice. Which set contains only physical properties? Remember, physical properties involve those properties that do not result in the substance changing into another substance by a chemical reaction. So physical properties are not involving chemical reactions. All right then, let's take a look at physical properties. The first set, boiling point, solubility, viscosity. Those are three physical properties. The boiling point is the temperature at which a substance goes from liquid to gaseous state. Changes in state of matter are physical. That is a physical property of a substance. Solubility is how well a substance dissolves in a particular solvent. That would be physical, because when you dissolve it, the substance is still there. You can get it back out after you dissolved it. There has not been a chemical change. Viscosity is a new word. We probably haven't talked too much about viscosity. Viscosity is how resistant a substance is to flowing. Well, molasses does not flow very well. Oil flows better. They have different viscosities, but their flowing does not change them into something else. Letter B, the melting point, that's physical. The temperature at which something goes from liquid to solid state. How something smells is physical. If something is giving off a smell when you put it together with something else, that could be evidence of a chemical change if that odor is being produced as the substance is chemically reacting. But the odor itself for a given compound is a physical property. Does the substance react in the presence of light? Certain compounds will decompose in the presence of light. That would be chemical, because the substance is changing when exposed to light. Density. You can measure its mass, you can measure its volume to find its density. That doesn't change what's there. The temperature at which a liquid goes to a solid is its freezing point. That doesn't change what is there. When something freezes, it is the same thing. Whether something burns or not, its flammability, that's chemical, because after it's burned, it's changed. The color of something, physical. How something tastes is physical. Whether something rusts or not is chemical, because after it rusts, it's no longer the same substance. Which set contains only extensive properties? Extensive properties are those properties. Question 48, extensive properties. Once again, extensive properties. Extensive properties are those properties that if you extend how much is there, it changes. If you add more, it changes. So extensive properties matter how much is there. The texture of something in green here, green, I'm saying it doesn't matter how much is there. The red ones matter how much is there. The texture of something doesn't matter how much is there. Volume does. If you add more to it, the volume increases. Density doesn't matter how much is there. That's intensive. The density does depend on the mass. Mass matters how much is there. Density does depend on the volume. The volume matters how much is there. But density is mass divided by volume. So if you add more, the mass of something goes up, so does the volume. So the density of a particular substance does not depend on how much is there. Because if the mass goes up and the volume goes up, the number stays the same. The boiling point of something, the temperature at which it boils doesn't change on how much is there. Boiling point. The boiling point of water, 100 Celsius. If you have a gallon of water, you have to get it to 100 Celsius to boil it. But it takes more heat to get a gallon of water to 100 than it would a thimbleful. A thimbleful of water will begin boiling at 100 Celsius, the same as a whole bucketful or whatever. But it takes less heat to get a thimbleful up. Heat does matter how much is there. Heat is extensive. The more of something you have, the more heat it takes to get its temperature to go up. The state of matter doesn't matter how much is there. If it's wintertime and you squirt a drop of water on the driveway, that drop of water will go to a solid if it's cold out. but so would a gallon. If you leave a gallon of water out in the wintertime, it will also freeze. The state of matter depends on the temperature it's at, not how much is there. The area, how much area something has, matters obviously how much is there. The longer the length, the longer the width, the bigger the area. The color of something doesn't matter how much is there. As we've mentioned, the temperature of something doesn't matter how much is there. A bucket of water at room temperature is room temperature. If you have a thimble full of water in that same room, it will also be room temperature. The mass of something matters how much is there. If you add more stuff on a balance, the mass goes up. So does the weight. If you add string to a strand of string and its length increases, the length of the string increases, those three things are all extensive. And now we move to our problem calculating the density of a medallion that is found on a beach. To get the mass of the medallion, it was placed on a balance, and the mass is 26.25 grams. So the mass of the medallion is 26.25 grams. They used the displacement method. To find density, we need the mass and the volume. Density is mass divided by volume. So to get the mass, they put it on a balance, 26.25. To find the volume of the medallion, they're using the displacement method. An object will displace its own volume when it's placed in water. So they filled a graduated cylinder to the 20 milliliter mark. Then they carefully placed the medallion in the graduated cylinder and the water went up to the 22.5 milliliter mark. So to find the volume of that medallion, the initial volume in the graduated cylinder was 20. The water went up to 22.5 when you dropped the medallion in there. So it went from 20 up to 22.5. So the volume of the medallion is the volume that ended at, V final, minus the volume in the graduated cylinder initially, which was 20. 22.5 divided by, or minus 20, the volume of the medallion is 2.5. So the mass of the medallion is 26. The volume is 2.5. Density is mass of the medallion, 26.25, divided by the volume of the medallion, which is 2.5. 26.25 divided by 2.5 is 10.5. 26.25 divided by 2.5 is 10.5. The unit is gram over milliliter. So I now know the density of that medallion. It's 10.5. So I come up to our given. Tin is 7.31. Copper is 8.98. Silver, there it is, 10.5. That is a silver medallion. It's not gold. The density of gold is 19.32. So the answer to number 49 is C. It must be silver. In the problem above, if the medallion was an alloy, it could be bronze. This is true or false. They're saying it could be bronze, which is copper and tin. Well, the medallion's 10.5. The density of copper is 8.98. The density of tin is 7.3. So an alloy of tin and copper would be between 7.3 and 8.98. It can't be, because it can't be an alloy of these two, because the density would have to be between those two. There's no way it's an alloy of those two since its density is 10. That's false. Palladium has a density of 11.9. Palladium is a very precious metal. It's actually more expensive than gold now because of its scarcity. But could this medallion be an alloy of palladium or palladium, which is 11.9, and copper? Well, if it's an alloy of palladium and copper, the density should be between palladiums, which is 11.9 because it's a mixture of the two, so it should be an average of the two. Palladium is 11.9. We saw up there that copper is 8.98. 10.5 is between 8.98 and 11.9. It actually could be an alloy of palladium or palladium and copper. Number 52. Formula unit gives the regular repeating pattern of ions in a crystal. That is correct. That is the definition of formula unit. A formula unit gives you the pattern of a crystal lattice. So right here is a crystal lattice. Chloride ion, sodium ion, chloride ion, sodium ion, negative, positive, negative, positive, negative, positive. What's the pattern of this crystal? It's for every one positive sodium, there's one negative chloride. For every one positive sodium, there's one negative chloride. That's what a formula unit is. It's the pattern, sodium chloride, sodium and a chloride. That's the pattern of the crystal. That's what a formula unit is. Physical changes, the 4 S's. Size is one of them. Shape is one of them. State of matter is one of them. And is it soluble? Solubility is one of them. How well it dissolves in something else. Yes, those are all physical changes. The formation of salt water. When you make salt water, salt is the solute, water is the solvent. Well, salt water is actually a solution. A solution is a homogeneous mixture. And a homogeneous mixture can quite often be salt being pulled apart by the solvent water. The thing that gets pulled apart is the solute. The thing that does the pulling apart is the solvent. That is correct. Physical properties could include strength, how strong something is. In other words, what forces it can withstand. Yep, that would be a physical property. The ability to conduct electricity or heat. That's physical. If something conducts electricity or heat, it hasn't changed itself. What it melts at is a physical property, and what it dissolves in are all physical properties. True. Mass is the measurement of the amount of space something occupies. No, 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 no. Volume is the space. Mass is the amount of matter. That's false. 57. Pure in chemistry means it must be an element. Oh, no, no, no. Pure in chemistry means only one type of thing is there. Pure can be an element, or pure can also be a compound. Matter is anything with mass and volume. Number 58. True, that is correct. Matter is something with mass that takes up space. And 59. Chemical changes result in the formation of a substance that has different properties than what joined to form it. That is true. When the reactants join to form a product, the reactants lose their properties and form something with new properties different than what the reactants had. That is true. We're going to stop here with number 59 on this video. Thank you very much for watching. The next video will pick up with question 60.